Welcome back, everybody. Today we're diving deep into the story of a physics giant you might not know as well as like Einstein or Newton. But trust me, this guy's impact is just as profound. We're talking to Joseph John Thomson, and we're going to see how his work, especially his discovery of the electron, ripples through history and sets the stage for, well, the mind-blowing world of quantum technology.
It really is amazing how often these big scientific breakthroughs, they kind of seem to come out of left field, you know? Thompson's a perfect example. His journey, it really challenges that whole stereotype of a scientist just being born a genius.
Okay, so paint a picture for us. What was Thomson's background like?
All right.
Our main source, by the way, for this deep dive is an essay by Jorgo Schneeppert. It's titled Joseph J. Thomson, Entdecker des Elektrons und Quantenpienia.
Well, as Schneeppert points out, Thompson's early life, it wasn't exactly a silver spoon story. His family struggled financially and he lost his father at a young age. But here's the thing. His passion for knowledge, it just burned bright. Keep this. He started university at 14.
14. Wow. I was definitely not tackling advanced physics at 14. I'm sensing a theme here,
Yeah.
like a relentless curiosity driving him forward.
Absolutely. And I think that curiosity was fueled by the giants who came before him. You know Maxwell Faraday. These were the rock stars of physics back then, pushing the boundaries of what we knew about electromagnetism and the very nature of matter. Thomson, he was drawn to those big questions too.
So he's standing on the shoulders of giants ready to make his own mark. And speaking of making a mark, let's talk about the discovery that put him on the map, the electron. Now, this is where it gets really exciting, right?
Oh, absolutely. I mean, imagine this. For centuries, people believed that atoms were the smallest things, the indivisible building blocks of the universe. Then, in 1897, Thomson comes along with his experiments on cathode rays, and bam! He discovers something even tinier inside the atom.
That must have been a monumental shift in thinking. It's like finding out there's a whole hidden world beneath the one you thought you knew. So he basically shattered the existing model of the atom.
He did. Schneeppert really highlights this moment as truly pivotal. The discovery of the first subatomic particle. It was a game changer. And it's funny to think about it now, but Thomson initially called these particles corpuscles. It wasn't until later that the term electron stuck.
Corpuscles. Yeah, it's a bit clunky, isn't it? Electron definitely has a better ring to it.
Yeah.
But what's really fascinating to me is that this tiny particle, the electron, it's a universal building block. It's a part of everything around us.
Exactly. It really underscores a fundamental truth about the universe. Things are often much more complex than they appear on the surface. And sometimes it takes a curious mind like Thomson's to peel back those layers, to reveal the hidden wonders beneath.
Okay, so the atom wasn't the smallest thing anymore. How did scientists, including Thomson himself, try to picture this new reality?
Well, Thomson came up with what we now call the plum pudding model of the atom. Imagine this. The pudding is a sphere of positive charge, and the plums, scattered throughout, are the negatively charged electrons.
Plum pudding. It's an oddly delicious way to describe an atom. But like a lot of scientific models, it wasn't the complete picture of part.
Yeah, it was an important step at the time, but it was later refined by one of Thomson's own students, Ernest Rutherford. You know him. He's the one who proposed the model with a dense, positively charged nucleus at the center of the atom.
It's amazing to see how these discoveries build upon each other. It's like pieces of a giant scientific puzzle being assembled over time. And Thomson's work was a key part of that. But his legacy goes way beyond just the electron and this early model of the atom, don't you think?
Oh, absolutely. What often gets overlooked is that Thomson wasn't just a brilliant scientist. He was a phenomenal leader and mentor, too. He basically transformed the Cavendish laboratory into the place to be for physics research.
So it was about more than just making discoveries himself. He created an environment where groundbreaking science could flourish.
Exactly. Schneeppert really emphasizes that, too. Thomson fostered collaboration and nurtured young talent. His book, Conduction of Electricity Through Gases, had a huge influence on later generations of physicists.
So under his leadership, the Cavendish lab became a breeding ground for new ideas and discoveries.
Yeah.
Makes you wish you could hop in a time machine and visit that lab during its heyday.
Doesn't it? Can you imagine the conversations, the experiments, the sheer intellectual energy in that place? It must have been incredible. And to think so many technologies we rely on today, from computers to medical imaging, all of them trace their roots back to the kind of work that was happening under Thomson's leadership.
That's a pretty incredible legacy. But there's one more piece of the puzzle we need to explore. The connection between Thomson's work and the mind-bending world of quantum technology. How does a physicist working over a century ago tie into something as futuristic sounding as quantum technology?
That's where things get really interesting. Remember those tiny electrons that Thomson discovered? Well, it turns out they hold the key to unlocking some of the most incredible possibilities of the quantum world. When you think about quantum technology, you probably picture things like super fast computers and unbreakable codes, right? But the foundation for all of that lies in the work of physicists like Thomson.
So even though he was working long before quantum mechanics really took off, his research laid the groundwork for understanding and manipulating those tiny electrons.
Exactly. Thomson's incredibly precise measurements and the methods he developed were revolutionary. They weren't just observing electrons, they were figuring out how to control them.
Okay, I'm intrigued. Explain this to me like I'm 5. How does controlling electrons lead to things like quantum computers? Those things still sound like science fiction to me.
It's not magic, but it's pretty close. Let's start with the basics. A regular computer bit is either a 0 or a 1, right? A quantum bit or qubit. It can be both 0 and 1 at the same time. It's this mind-bending concept called superposition.
Wait, hold on. A bit can be two things at once. How is that even possible?
That's the weird and wonderful world of quantum mechanics. And because qubits can be in multiple states simultaneously, quantum computers can perform calculations in ways that are just impossible for classical computers.
Okay, that's pretty wild. So Thomson's work with electrons helped open the door to harnessing these strange quantum properties.
Precisely. And it goes beyond just his experiments. Thomson's theoretical work on atomic structure was also incredibly important. It laid the foundation for fields like quantum field theory and quantum chemistry, which are essential for understanding the universe at its most fundamental level.
So this one guy working with equipment that would probably look like museum pieces to us today, he managed to spark a scientific revolution that's still unfolding. That's mind-blowing. Schnappat really drives that point home in his essay.
It really is. And what's even more remarkable is that Thomson's influence wasn't limited to physics. He was a leader who encouraged collaboration across disciplines, something we're seeing more and more of in quantum technology research today.
That makes sense. Quantum technology isn't just about physics anymore, is it? It's this incredible fusion of physics engineering, computer science, all these fields coming together to push the boundaries of what's possible.
It's a beautiful synergy. You could argue that Thomson, with his emphasis on collaboration at the Cavendish Laboratory, he was ahead of his time in fostering that kind of scientific ecosystem.
So as we marvel at the mind-blowing possibilities of quantum technology, we have to remember Joseph John Thomson, the electron whisperer, as I like to call him. He helped set it all in motion. But here's a question. What was the driving force behind his work? What made him tick?
Schneppat says that Thomson was driven by a deep curiosity about the fundamental building blocks of the universe. He wanted to know what the world was made of at its most basic level.
That's a pretty fundamental question. It's like the ultimate, what is the meaning of life, but for a physicist, right? I'm sure a lot of our listeners can relate to that drive to understand the world around us.
Absolutely. And what's so powerful about that kind of questioning is that it leads to discoveries with far-reaching consequences. The quest to understand the electron wasn't just about abstract knowledge, it was about unlocking the potential for technologies that could reshape our world.
So Thomson's curiosity led to the electron. The electron led to quantum mechanics. And quantum mechanics is leading to, well, who knows what. It's like a chain reaction of scientific progress.
It really is, and it's a testament to the power of asking the right questions, because sometimes those questions lead us down paths we never could have imagined.
Speaking of paths, it's time to explore the next part of Thomson's journey. We've talked about his discoveries and his leadership, but what about his lasting impact on science and technology? That's what I'm really curious about.
Well, to understand that impact, we need to delve into the legacy of his work, see how those ripples he created are still shaping the world today.
Yeah, it's really quite something. When you look at the breadth of Thomson's impact, it wasn't just about the electron itself. It was about opening up this whole new realm of scientific inquiry. It's like he gave us a new lens through which to view the universe, one that revealed this hidden world of subatomic particles. And that discovery had a ripple effect leading to quantum mechanics and all the mind-blowing possibilities that come with it.
Right, and a lot of people don't realize this, but Thomson's work also had a huge impact on things like medical imaging.
Oh yeah, X-rays, CT scans. Those technologies rely on our understanding of how electrons interact with matter,
Exactly. And let's not forget about things like electron microscopes.
which allow us to see objects at the atomic level.
It's incredible to think that Thomson's work from over a century ago is still shaping the tools we use to explore and understand the world around us.
It really is a testament to the power of fundamental research. Sometimes it's hard to predict what the practical applications of a scientific discovery will be. But when you unlock a fundamental truth about the universe, it often leads to innovations that we couldn't have even imagined.
That's so true. And you know something else that's really interesting about Thomson? He was a strong advocate for the importance of science education.
Oh, really?
He believed that everyone should have the opportunity to learn about science and its impact on our lives.
That's pretty forward-thinking for a scientist working in the early 20th century.
It was. And Schneeplatt actually quotes Thomson in his essay saying, "The more science we have in the world, the less room there will be for dogma."
I love that. It speaks to the power of science to challenge our assumptions and expand our understanding of the world.
Exactly. And I think that's a message that's more relevant than ever today.
Absolutely. In a world where misinformation and conspiracy theories can spread like wildfire, we need to champion science and critical thinking.
Couldn't agree more.
So to all our listeners out there, embrace your curiosity, never stop questioning, and remember the legacy of Joseph John Thomson, a scientist who helped to illuminate the hidden wonders of the universe.
And whose impact continues to be felt to this day.
It's pretty amazing, isn't it, how Thomson's work continues to resonate more than a century later.
It is. Schneeplatt makes a really interesting point about this in his essay. He talks about how Thomson's discoveries weren't just these isolated events. They were part of a much larger scientific revolution that was happening at the turn of the 20th century.
Oh yeah, that was a time of incredible upheaval in the world of physics, wasn't it?
It was. You had Einstein developing his theory of relativity, Planck was laying the groundwork for quantum mechanics, and Thomson was right there in the thick of it all, probing the structure of the atom and revealing the existence of the electron.
So Thomson's work helped to usher in this new era of physics, one that fundamentally changed our understanding of the universe.
Exactly. And it's important to remember, Thomson wasn't just making these discoveries in isolation, he was also nurturing the next generation of scientists.
Right, we talked about his leadership at the Cavendish Lab and how he fostered this incredibly collaborative environment.
Exactly. And many of those young scientists went on to make their own groundbreaking contributions to physics. People like Ernest Rutherford, Niels Bohr. These were Thomson's students.
It's like a scientific family tree branching out and shaping the course of modern physics.
It really is. And you know, it's not just about the direct lineage of scientists either. It's also about the way Thomson's ideas inspired and influenced countless others. His work on the electron, for example, it laid the foundation for our understanding of electricity, magnetism, and the nature of light itself.
So his impact extends far beyond just the realm of atomic physics.
Absolutely. It ripples out into all these different areas of science and technology.
It's mind-blowing to think about the lasting legacy of this one scientist.
It is. And it's a reminder, I think, that even the smallest discoveries can have a ripple effect that changes the world.
So as we wrap up this deep dive into the life and legacy of Joseph John Thomson, what's the one key takeaway you want our listeners to remember?
I think it's the importance of curiosity and the power of asking fundamental questions. Thomson wasn't afraid to challenge the status quo, to delve into the unknown, and that's what led him to his groundbreaking discoveries.
Well said. It's a great reminder that science is a journey of exploration, and that sometimes the most unexpected discoveries can lead to the greatest breakthroughs. So to all our listeners out there, keep exploring, keep asking questions. And who knows, maybe you'll be the next one to uncover a hidden wonder of the universe.
Absolutely. The spirit of scientific inquiry is what drives us forward.
And on that note, I think it's time to wrap up our deep dive. Huge thanks to you for joining us today and sharing your insights.
It's been my pleasure.
And to all our listeners out there, thanks for tuning in. Be sure to check out the show notes for links to learn more about Joseph John Thomson and the incredible science he inspired. Until next time, keep diving deep.